Welcome to FOB TV, the future of business. I'm your host, Kevin Benedict. I'm a futurist and lecturer here at TCS, and I want to welcome everyone for joining the program today. Our guest, I'm really excited to introduce him today. His name is Subhash Sakorikar. He's the Global Head, Industry Excellence, TCS Manufacturing Business Group. And we're going to talk all about manufacturing and emerging technologies and the direction of manufacturing in the future. So thank you again for joining us today, Subhash.
Yes, thank you. Thanks, Kevin, for having me here. And I'm glad. I'm dialing in from my hometown in Detroit, slightly north of that, right in the manufacturing.
Oh, yeah. Aren't you getting a massive snowstorm right now?
It is just starting now, right? So we are. That's why I chose to be, fully safe here.
That's awesome. So now talk to me. The recent advancements in AI must really impact your area of responsibility, manufacturing. Tell me about that.
Yeah, I think AI has impacted all the industries. So it can't be, untouching. People thought earlier that it will be in just the conversations, maybe commerce, some retail and things like those. But it's big. So wherever there is a data, there is AI. I mean, you can imagine it that way. So in manufacturing, there is, of course, different type of data, right? It's not about social conversations that people do and, all the news clippings. No, it's about the hardcore data that is generated by machines, right? So you'd be wondering that what kind of data machines generate, right? So they generate all the information about the temperature, sensors, dimensions, colors, the pictures, the thermal images, so on and so forth. So you have a whole set of data that is now available for artificial intelligence to be applied. And sometimes this does a better job than human being, because the amount of processing power that you have, amount of consuming of data that you can, and the analytics that you can do out of it is tremendous, I think. So we have seen this when this is superimposed by the data that is about the machines, about the things that can control the machines, right? And then the impact of this AI is huge. And then we are extending it further. There are a lot of applications, and probably we'll talk a little more about those. But coming to the machine-generated data and the systems that control those machines, we typically call the enterprise systems. There are a lot of data in the ERPs, the PLMs, and MES systems of the world. All that, when it is related to each other, that creates a tremendous potential for not only productivity improvement, but also ensuring the quality and timeliness of the stuff that you produce.
Oh, yeah. Because when you look at this, it's the convergence of not just one thing, but many things, right? It's the convergence of AI and automation and all that data and the ability to generate a digital twin and then layer over that huge heavy layer of intelligence. Now, how is that going to change the whole manufacturing value chain?
Yeah, so if you look at the whole manufacturing value chain, we typically start with, let's say, requirement gathering from the customers, right? That what does the customer would need or define. Sometimes you don't have to, sometimes the customers just don't know, right? What do they need? So you make something, but it starts with the concept, then the design, then the actual sourcing of the components, then the actual shop floor manufacturing, prototyping, getting it to scale, and then selling, servicing. And most of the manufacturing products are long life products, right? They're installed for 10 years, 20 years in the field, depending on what kind of product you're talking about. And then you get the data which is used in the field. So there's a full life cycle of the manufacturing, right? From the concept to the end usage, right? And at every point of time, you either generate the data or you use the data. And you can have you mentioned about the digital twins, right? And I don't think that we have, in manufacturing, we have the digital twin for the entire life cycle, but there are components and pieces of it, which many manufacturers have tried. And at TCS, we have also helped them in realizing those things. For example, you have a digital twin of a product. You have a digital twin of a plant, right? You have a digital twin of the usage where the product is being used, which causes the in-use digital twins. And then you also have the digital twins of the processes, like let's say the supply chain or the of digital twin, which you don't see in the physical form. What all I described before were all the physical products, and then you have a digital twin of that. You can also have a digital twin of something which is not physical. For example, supply chain process, right, which is in digital, but you have a complete twin of how actually the supply chain is operating, how actually the logistics is operating, and then you can do a lot of simulations, to not only control the things but also predict what could go wrong if those things are not controlled. So you have a digital twins, and then there are integrated twins, right? You can, if you have to work out a digital twin of a product and then a factory and integrate with the suppliers, this has a tremendous potential of transforming not only the efficiency and usage of the products, but also the value to the customer.
So, Subhash, will all these capabilities and the ability to have this really intense visibility of everything that's going on, will that ultimately impact the geographic location of factories? Well, will that enhance the ability to nearshore it or reshore it? Yeah. These kind of factories because of that, or how's it going to impact it?
Yeah, so I think if you look at the way it is, the world has operated last 2 decades. I would not go too long back, but it's the philosophy of design anywhere, build anywhere, and sell anywhere. So you can pretty much these capabilities were developed to have the lowest cost available to the end customers, and hence you have the best designer. You are designing, let's say, in Detroit, an automotive vehicle, but you will not have all the best engineers here, right? You may have somebody sitting in Europe, somebody sitting in Brazil, right? So you have these platforms which can enable the design anywhere concept, right? The gone of the equation, the days when we used to think that everything has to be at one place. Now, with all the technologies available, you can have the concurrent engineering. The three guys designing three different things which will be integrated in the future together, right? But sitting at independent locations, independent times, and you can render those designs virtually anywhere, right? So all this is possible with the amount of connectivity and the technology that is available, and you get the best of the breed for everything. Likewise for manufacturing, if you have to transship some designs, right? Gone are the days when you used to ship those blue films, the blue printouts, large go. No, it's long back, right? We don't even remember that. Hey, does somebody take any printout of a design? Nobody, right? So you can actually create the 3D models, 3D printing, and then you transship them, and then you can manufacture it anywhere. So and then sell anywhere, right? Which is where the customer is sitting. You can have the requirements, dimensions, the operating conditions, all those inputs which are required for design, literally taking that feedback virtually, right, from anywhere, and then transship the design. So this is the power which is available. And I don't think that, yes, if you talk about the transshipment or the relocations of the factories because of a lot of geopolitical considerations, everybody wants to build in their own countries, for example. Digital technologies make it faster, right? Because now you can pretty much have the digital factory transfer to a different location and stand up a physical infrastructure through the digital twin. And you can mimic the entire factory which was there somewhere else, thousands of miles away, very quickly and precisely in another location for choice, right?
Wow.
So that's the freedom that the technologies give on this. So creating a digital twin, in fact, a lot of time we start digital first, right? Even for the product concept, and we have something called as model-based system engineering, right? Which is designing by keeping the end product in mind. And as let's say somebody is designing an axle, somebody is designing a transmission, somebody is a tire. Imagine if all of this is working together and you are able to see the entire final model as you are developing it, rather than designing each component and then waiting for that assembly to happen. Now, with this model-based system engineering and the artificial intelligence and the digital twins of these products, you are able to compress the cycle time. Let's say if typically you would launch a brand new product in 24 months, with these technologies, you are able to launch it nearly in half time.
Wow.
So that's the power we see. Yeah.
That's powerful. So help us envision the fully autonomous factory, Subhash. we read about autonomous in the context of vehicles and airplanes and drones and all these kinds of things. But an autonomous factory, what does that factory of the future look like? Walk us through that.
Yeah. So the fully autonomous factory is something a dream and a reality both. Right? I would say dream because there are a lot of product segments which are yet to achieve what is required as the ingredients for a fully autonomous factory. While there are some segments of the products where it is attained. For example, if you talk about the cell phones or the computers assemblies, right? They are almost near full autonomous kind of factories. You can configure the factories very easily. You have a variety of SKUs getting produced on the same lines on different configurations of laptops. You don't need different factories for different things, right? You can reconfigure, you can produce number of things, and pretty much one or two workers who are actually just overseeing. But all the assembly is pretty much fully autonomous, right? So there is one extreme. But if you look at the other industries of heavy equipment or airplanes or automotives, it is a long way to go right now, and it depends on the type of components, type of systems that support, and the evolution. And another important factor is not many of the industries were all greenfield, right? They evolved over a period of time. So you modernize the plants rather than establishing a brand new fully autonomous plants. So the industries that evolved a little later in the years are more akin to adopt the fully autonomous factories because there was nothing existing. They have to build a brand fresh, right? While in the automotive, airplane, and a lot of industrial equipment manufacturing, there's a huge investment which is sitting and that needs to be modernized to make it autonomous. So there is a time lag difference because of the products and the technologies of the past. And also, but yes, there are product lines for which there are fully autonomous factories now in reality as well, as we told. And it has a lot to do with the upstream work, right? When you say fully autonomous, it takes a lot of time, a lot of efforts and systems to plan, right? It has been realized more for the assembly than for the actual manufacturing, say machining, welding, buffing, galvanizing. Those processes are not yet fully autonomous, right? But a lot of things on the assembly are being attempted to make it fully autonomous, provided lining up the supply chain and components and parts ahead of time with the right sequencing and scheduling of assemblies, right? So I would say assemblies, yes, there are a lot of product lines where fully autonomous is there, but the actual manufacturing, there is still a way to go. Yeah.
Years ago, early in my career, I was working at Micron Electronics, and we were building laptops and computers. And I was the B2B e-commerce manager. And so my responsibility was to try and work to automate the assembly lines to make sure that all the parts ended up on the assembly line at the right time, just in time. But, we had a big vision, but we ran into all kinds of roadblocks
Right.
where the data wasn't even available to us except on a spreadsheet.
Yeah,
and so it's like,
as I said, it's not only about the product, but it's also about the supporting systems, and particularly the supply chain, that you need to have sequencing, scheduling, slotting. And what happens when the customer changes the order, the customer changes the needs, and then your ability to be agile to configure the products in near real time. I wouldn't say real time, but near real time basis also counts for how much autonomous you can.
Oh, yeah. So walk us through some of those methodologies that need to be in place, some of those frameworks, those layers. What are the many different layers that are really need to be there, the foundational layers that will help modernize, at least move toward that autonomous factory?
Yeah, so there are a number of building blocks, I would say, if you have to move towards the autonomous factory, and which we are envisioning as the factory of the future as well, right? The biggest, the starting point is the bill of materials, right? Where you start with the right bombs, your accuracy of bombs is very, very important. The second building block is on the supply chain side, right? The accuracy of whether it is just in time, ability to be agile in supply chain. And then the automation, right? It's another very, very important thing to have the factory automation done. And we are envisioning that, yes, there are robots which are, the cohabitating with the humans. So you have the factories where the cobots, as we call the term, are working together hand in hand with the and fully autonomous factory. We are envisioning as something which is where there's no human labor, right? Now there are tasks that are done by humans with certain intelligence. So the building blocks of AI is very important to develop in the context of the product and assembly lines to enable the factory, fully autonomous factory, I would say, right? So it's the automation, the AI, the supply chain, and the bill of materials. All of them need to be in sync to make it working. And the digital twins are helping in envisioning that a little faster. So I would say that it is a very core building block which embodies the AI data, all it. But today we have the factories which do not have even the sensors, right? I mean, if we are talking about Industry 5.0, there are factories which are still producing today, which is not even Industry 1.0 or 2.0 site, right? And they're still producing. We can't say that they are not useful at all, right? So the adoption may take a little more time, but I think we have to work on these four key building blocks as we enable the autonomous factory.
In one of the things I think we should just be clear on is that the autonomous factory may not actually be our goal. The goal might be some optimized environment, right? With a lot of humans and a lot of automation at the same time. And there's probably different ways of dividing up the tasks so that robots and automated systems can do some things better than humans, and humans can do other things better. So I don't want to suggest that necessarily is even the goal. It's the modernizing and optimization that's the goal. Two other points that are so important to us when we look at optimizing a manufacturing environment are prevention and prediction. Talk to us about that.
Yeah, I think this is a great point to ponder on with the availability of data and AI and the capabilities that are there and we are developing. Not only the prevention and prediction is important, but also the action. So that's where the new frameworks of agentic AI are coming in place. That if something is going wrong, you are able to predict. You're also able to prescribe the right course of action. And now you can autonomously act to correct it. Right. So it's very important, particularly when in manufacturing, you're talking about a digital and physical world existing together. And the prediction and the action post that is super important. So digital twins do make that a lot easier, because now you can predict what's going to happen. You can simulate the amount of the environment. Let's say if you're designing a shop floor factory, and then you suddenly have a product which is slightly longer than what it would be, and you can digitally simulate where it will fall. And your entire digital factory simulation allows you to predict what things may go wrong if something new comes up on the assembly line. The prescription is, what can you do about it, right? So can you change certain layouts? Can you make it shorter? What is the option solution available? You can digitally simulate the answers. And then if you're in a fully autonomous world that we just spoke about, you can actually reconfigure the factory. You can technically move the stations, make the place for the things that are going to come. So I just gave an example of a new product coming on an assembly line, which is configurable. You can actually predict, prescribe, and act fully autonomously with these technologies, right? So that's the things. Now we have been developing at TCS a lot of accelerators in enabling those. So we have the factory of the future concept. We have a lot of labs which are experimenting with this, so that you are able to simulate all of this a little better. Right?
So decision making is going to be done in completely different ways then, right? If you have the ability to simulate, you have the ability to make these algorithmic or just data-driven decisions, and then you have the ability for an automated environment to act on those. That changes everything, and I would assume that that's going to speed up the process a whole lot more than it does today, because so many more things can be automated in the decision-making tree. Is that how you see it?
Yeah, so I think the data gives you a lot of things about the past and a few trends on the future. And for an effective decisions, you not only need an insight, which the data can give, but you also need a foresight, right? So which the trends, which is something which is the correlation with the other data, which is sitting outside the systems, can make it, right? For example, if you are short of some supply on an assembly line, and your past algorithms will search for your possible suppliers, and then will recommend that, okay, based on this is the shortage coming up, and now these are the potential suppliers. But the foresight would tell you which one to order. Now, if you know that there is a likely hurricane coming in that particular part of the world, even if that is an approved supplier, you're not going to order there, right? Because you know that there is a disruption which is likely, or there are some geopolitical things that are happening. So you need the data insights, and from correlational databases, the foresight for the right decision to make, right? So that's what this is evolving, and we are developing a lot of models by using the internal and external data to generate. And then a lot of people are talking about the large language models and to be contextual. Yes, they are super important today because the decision is made in a context. And if that context to AI will come by not only training, but also looking at refining, right? So you have to train the data models and you have to refine them so that you have the right decisions made for the time. But yes, you rightly said that decision making would be much different and much more data based, insight based, and data driven foresight based. That's what I would say.
So it's not just the decisions that have to be made within the context of a process. It's also decisions have to be made, as you pointed out, in the right context. And as we have more and more machines around us that are working autonomous, they're going to have to not run into us. They're going to have to not collide. They're going to have to adjust when there's a pallet that has fallen over. All of these things mean that real-time decision making is going to be more and more critical. And that kind of leads us into the discussion of edge computing. What do you see as the increasing role and importance of edge computing?
Yeah. So I think one thing which we must see when we talk about AI and the decision making, and it's not one technology. I think we should never ever assume that it's only the data and the AI that will govern. Is the amount of, let's say, the other technologies which are communication technologies, right? Today, and all of these technologies develop in parallel, right? So the development of 5G, 6G, Wi-Fi 6. All this is happening in parallel, right? Then you have the way the things are powered, whether it is electrification or the solar and different, that's happening in parallel. So they are all different technologies of communication. Quantum computing, for example, is evolving independently. The future and the things that we're discussing will lie on the conglomeration and right confluence of these technologies to act together to achieve that purpose. So AI is not independent, right? You generate the data, you need the sensors, whether you have the thermal sensors, you have visual sensors, you have camera-based, you have so many things, right? So each technology, the combination of that is something which will decide. Now, you spoke about the edge computing as well. So now how much of that you keep it on edge versus how much of you keep it on the cloud, for example, or remote. It also depends upon the example that I just quoted on the communication technologies, right? So if you are able to have a lot of good computing available and decision making available at the edge on the devices, yes, it definitely counts. It is faster, safer, but sometimes the context is also missed, right? So you need to work out that balance of what you would keep there, because you don't leverage the power of the the exponential power of the computing that is available it could not be leveraged for only the edge ones, right?
Mm-hmm.
So you need to balance out the right combination of technologies to achieve the objective.
One of the goals that a lot of improvement and optimization in manufacturing have is the ability to more quickly and in an agile fashion be able to customize and personalize the production of specific products. And a lot of this is enabled through all these different processes and improvements and technologies and methodologies and frameworks. Talk to us about that capability and what it takes to really achieve that dream.
Right. So I define the personalization, and it's a big theme actually. If you recall the old, very famous statement, Ford Model T, right? I can give you as many variants and as many colors so long as it's black, right? So because each variant in the product dimensions, the product attributes, create the complexities exponentially, right? You just add one color, and then you have the combination that, hey, whether the red door will arrive at the same time as the red body chassis, right? And then you add more the complexities on each of the dimensions to achieve that. The way of achieving that is the higher level customization and lower level commonization. That's very, very fundamental. When you design the products for the customizable options, so long as you're able to keep at the lower level a lot of things common, and at the higher level the attributes are different, it works out very, very cost optimal, right? So I'll just expand on this example. If you're building, let's say, I'm in the car city, so I have to talk a little more about the cars, obviously, right? Being in Detroit, you can't avoid that. So if you to build, if you have the building blocks of, let's say, of 6 varieties of tires only, right? And 5 varieties of roof rails, right?
Yeah.
And then you have 3 variety of this, and you define and make them as the common minimum things. And now when you start creating the combinations of this, the end customer gets a huge variety.
Yes.
But at the lower level, you have a lot of common. So I call that as a lower level commonization, higher level customizations, right? So that's what the customer would feel, that you are giving me a very unique what I wanted, but actually you are deriving out of something standard. So that balancing saves the cost quite a lot, particularly for the make to stock kind of products, right? Again, there are scenarios where you can't have this strategy. In manufacturing, we typically talk about different types of manufacturing strategies. You have make to stock, make to order, configured to order, engineered to order, depending upon the type of the product and customer needs. So this variety, which is the strategy, can best be optimized all across. In fact, we have seen it in shipbuilding, airplane building, or out of the cars or the air conditioners, right? This level of philosophy works pretty much well for many of the product lines there. So that's one very simple, but the digital technologies help a lot in achieving this objective, because you can, by having those common systems and by having those product attributes, you can easily source a similar part is sitting in which other vehicle or which other component. And now we are looking at the collaboration across competitors, right? So for deriving the cost down by commonizing various inputs, suppliers, various manufacturers are now collaborating with each other on finding the common components across the platforms, right? So you can optimize the cost of design, cost of manufacturing, cost of sourcing them, and still deliver the customized product to a customer, right?
So we've talked a lot about these visions and these dreams and how to accomplish those. Let's now shift our focus to the gaps. Where are there still gaps between that dream and where most companies are, and what kind of innovations are needed to fill those gaps?
Right. I think there are a number of areas where things need to evolve, particularly in the core manufacturing sector. I would say that high-tech manufacturing has moved a little faster space, just sheer volumes and the technologies. But the core manufacturing is yet to catch up. So a couple of them are the common standards, right? Let's say when you talk about the connected plant, digital twins, we need to have the common standards of connectivity, sensors, the way the information is taken and interpreted. That is yet to evolve. Okay, that's one piece. The second impediment, if I may, would be there is a large install base of the plants which are sitting out there and producing, which still need to be modernized. Nobody makes a plant for, let's say, 3 year or a 5 year. Right? Typically, you will say when the business case is made for a plant, it is lasting for 20 years, 30 years ROI. The payback period, for example, is very high, right? And those plants are not yet depreciated, and you would like to use them, and that prevents you from building a brand new conceptual things of autonomous. So there are some constraints. There is a certain level of automation that you can achieve on those plants by putting some sensors, but there are also limitations, right? So there is a catching up game that is yet to be happen. That's why you'll see that in the automotive world or even in the air conditioner, the new players, they have an advantage over others because they're starting fresh. There is nothing called legacy to modernize, right? So that's another gap which is there. And third is in the computing methods and computing power, right? How much you can outsource, how much each of them is doing it in house. And there are certain technologies which needs a shared platform, to save the cost per unit of product. So a number of things that are impacting the adoption of these. One more thing is on the past data. We must last 5 years were good in collecting a lot of data, but for a good number of parameters, there is not enough data available, right? So not everything was sensorized, not every data was recorded in the common formats or systems, right? So that is something which is still a WIP. So for some of them, it would be like changing the wheel when you're running the car.
Yes.
So that is the kind of thing that is also going on there. So
we call
different types depending on the type of company and scenario that you're talking about. Yeah.
Sometimes we call that the blind spots that remain, right?
Yep.
So you just don't have the data from that particular area of the business, and so you don't have the visibility to make the right kind of decisions. Well, I appreciate that, Subhash. This has been fascinating. You're right in the middle of where reality hits vision, and I appreciate all you've shared with us today. Thank you very much.
Likewise, appreciate your time, and it was a pleasure to talk to you.